In this video, we will learn the number names, place values, and the expanded form of numbers up to 5 digits. Numbers are very important to us. There are various situations in our life where numbers prove useful, such as for counting, measuring, labeling, for telling time, and many more. We can make any number using the digits, such as the number of students in a class, the price of a shirt, the price of a computer, etc. Expressing a number in digits is called a numeral. Small numbers can be read easily, but it can be difficult to read large numbers. Therefore, we use indicators to read numbers easily. The indicator is expressed from right to left. Some indicators are ones, tens, hundreds, thousands, 10,000s, which are represented by the capital letters O, T, H, TH, and TTH respectively. This number is expressed in words as 56,423. Usually, numbers are written without any indicators, but that can make it difficult to read and write large numbers. Commas make it easier for us to read large numbers. Commas are used to mark thousands. For this, the first comma is placed after the third digit from the right, that is, after the hundreds place. Now look at this number. This number is made up of digits 5, 6, 4, 2, and 3. But the value of each digit is different. In this way, the numerical value of a digit dependent on the position of a number is called as place value. The number can be expressed as the sum of the place values of the digits. These numbers can also be expanded in this way. This is called the expanded form of a number. In this way, we expand the number to show the value of each of its digits. Now, we can see that this number has a group of 5 10,000s, a group of 6 thousands, a group of 4 hundreds, a group of 2 tens, and 3 ones. Looking at many symbols and numbers, one can get confused as to which mathematical operation to do first. To avoid this confusion, we use brackets. Here, to understand that multiplication should be done first, we will write the operation of multiplication in brackets. Today, we learned number names, place values, and expanded form of numbers up to 5 digits. With the help of this video, we will see some examples of comparing numbers up to 5 digits, arranging them in order, and forming numbers. So far, we have learned about numbers up to 5 digits. Now let's find solutions to some examples related to them. Example. This is Anil's shop. Here are a few boxes of sweets which Anil has to arrange in order. But he is confused how to arrange them. Will you be able to help him? Now if you see, the cost of each box of sweets is different. This means they can be arranged in order by comparing their prices. First, we will identify which number is made up of how many digits. The smallest number will have the least number of digits, which makes 75 the smallest number. So, we will keep all the boxes worth rupees 75 at the bottom. If the number of digits is the same, then we will compare the leftmost digit of the numbers. That is, we will compare the place value of the numbers. Here, 1 is the smallest digit. That is, its place value is the smallest. So 125 is the smaller number as compared to the other two numbers. Let's place all the boxes worth rupees 125 on top of the boxes worth rupees 75. Now if we look at the remaining two numbers, the leftmost digit is the same. So we will compare the next number. This is also the same. So we will compare the next number. Here, the digit 5 is smaller than 8. So 215 is a smaller number than 218. Let us arrange the boxes worth rupees 215 over the boxes worth rupees 125. Now, we will keep the remaining boxes worth rupees 218 at the top. In this way, we have arranged all the boxes from the smallest number to the greatest number in ascending order. If the order is reversed, that is, if we arrange the boxes from the greatest number to the smallest number, then we will obtain the descending order. Anil is very relieved now that all the boxes have been placed in order. Next example. Make 3-digit numbers without repeating any of the given digits, that is, 5, 0, and 2. We can form numbers by putting the digits together. Like here, we form the number 502. By shifting the digits in this number, we can form some more numbers, but the condition is that it should be a 3-digit number. Are all these given numbers 3-digit numbers? Now look at this. Here, 025 and 052 are not 3-digit numbers. Why so? Because when 0 is written before a number, there is no change in the value of that number. That makes both 25 and 52 2-digit numbers. Therefore, you can make only these 3-digit numbers from the given digits. Next example. With the digits 9, 6, 3, 7, 4, form the largest or the greatest number and the smallest number by placing 9 in the tens place. Let's make the largest and smallest number with the given condition. According to the question, let's first write 9 in the tens place. For larger numbers, arrange the remaining digits in descending order, and for smaller numbers, arrange the remaining digits in ascending order. With this, we get 76,493 as the largest number and 34,697 as the smallest number. This would have given you a better understanding of numbers up to 5 digits. So, in this video, we saw some examples of comparing numbers up to 5 digits, arranging them in order, and forming numbers. Today, we will see some misconceptions related to numbers up to 5 digits. So far, we learned about numbers up to 5 digits, and now we will talk about some misconceptions related to them. Misconception 1. What will be the expanded form of the given number 86,697? 618. Sometimes, because we don't clearly understand the concept of expanded form of a number, we add 8 plus 6 plus 6 plus 1 plus 8, getting a value of 29, which is incorrect. Sometimes, we misunderstand that the expanded form of a given number means to add a zero at the end of the number. For some, expansion of a number means writing the number in letters or words, and thus we get the result 86,618, which again is incorrect. The correct understanding is that option 4 is the right answer. To clear this misconception, it is important to understand that the number 8 is at 10,000s place, 6 is at thousands place, at the hundreds place is 6, 1 is at the tens place, and 8 is in the ones place. Misconception 2. If we compare the digit 2 in the numbers 35,214 and 42,302, which one of the following statements is correct? Some students fail to understand the concept of place value, so they think that the 2 in the hundreds place is equal to the 2 in the units place or ones place. This is a misunderstanding. Sometimes it is known that the digit 2 is different in both numbers, and the reason behind it is not known. The correct understanding is that the digit 2 has different place value in these two numbers, so the digit 2 is different in both numbers. Misconception 3. Which is the smallest four-digit number using the digits 2, 3, 5 and 0? When 0 is written before a number, there is no change in the value of the number. So 0235 will be considered as 235, which is a three-digit number. Many times, without understanding the question, we select option 1 to be the correct answer since we see it as a four-digit number, beginning with the smallest digit 0. This is a misunderstanding. In order to write the smallest four-digit number, 2, 3, 5 are written in ascending order, but due to confusion as to where to put 0, it is often written after 5. This gives us option 2, which is incorrect. The correct understanding is that a number cannot begin with 0, so it should be written after the smallest non-zero number. With this understanding, the correct answer is 2035. So today, we saw certain misconceptions related to numbers of up to 5 digits. Hopefully, many of your misconceptions related to 5-digit numbers must have been resolved. In this video, we will learn numbers up to 6 digits, their place value and expanded form. Six-digit numbers can be useful in many places, such as representing the salary of a person, number of products sold by a company, number of votes received by a candidate in the elections, etc. This is Sarah. Sarah loves math. Today, she is making a very interesting pattern. Take a look. Can you guess how she's made this pattern? Okay, let's find out how she's made this pattern. The greatest single-digit number is 9, and if you add 1 to this, we get the number 10, which is the smallest two-digit number. Similarly, the greatest two-digit number is 99, and by adding 1 to this, we get 100, which is the smallest three-digit number. Continuing with the same pattern, we will get the smallest four-digit number, 1000, smallest five-digit number, 10,000, and similarly smallest six-digit number, 1 lakh. We have already learned about five-digit numbers And we know that the place value of the number determines the value of the number. If we add one digit to a 5-digit number, we will get a 6-digit number. By adding one digit, we need to add an indicator. Now for the 6th place, we will use lakh as the indicator. Using this, the place value of the digit 7 can now be written as 7 lakh. This is how we will write the expanded form of the number. This way, we have shown the expansion of each digit of the number. We now know that 7 is in the lakhs place, 5 is in the 10,000 place, 6 is in the thousands place, 4 in the hundreds place, 2 is in the tens place, and 3 is in the ones place. Multiple symbols and numbers can cause confusion, but with the use of brackets, we can simplify the process. Large numbers can be read and written easily with the use of indicators like the comma. To read large numbers, we use the Indian system of numeration or the international system of numeration. In the following videos, we will learn about this in detail. Today, we learned about numbers up to 6 digits, their place values, and expanded forms. In the next video, we will understand the same with some more examples. In the previous video, we learned about numbers up to 6 digits. In this video, we will look at examples to compare numbers up to 6 digits, arrange them in order, and form numbers. Represent the given number in both Indian as well as international system of numeration with the help of commas and write its number name and the expanded form. In the Indian system of numeration, commas are written from the third digit from the right to mark thousands and then after 2 digits to mark lakhs. The number name of this number is 3,54,572. In the international system of numeration, commas are written after the third digit from the right to mark thousands and then after 3 digits to mark million. Here, as there is no digit to mark million, we will not use a comma for millions. The number name of this number will be 3,54,572 and the expanded form of this number is as shown. The next example. Using each of the numbers given below, write the smallest and the greatest 6-digit number. Arrange the numbers in descending order to get the largest number from the given digits. This will give us the largest number, 9,76,531. Similarly, to get the smallest number from the given digits, arrange the numbers in ascending order. This will give us the smallest number, 1,35,679. The next example. A television manufacturing company has priced each television at Rs 8,999. If a trader buys 50 televisions, how much will he have to pay? Here, the price of one television is Rs 8,999. So this way, the price of 50 televisions will be the product of number of televisions and the price of one television, that is, 50 into 8,999. that is 4,49,950. You must have now developed a good understanding of numbers up to 6 digits. In this video, we learned to compare numbers up to 6 digits and arrange them in order and form numbers. So far, we have learnt about 6-digit numbers. In this video, we will learn about some misconceptions related to 6-digit numbers. Misconception 1. What are the predecessor and successor numbers of 2,56,550? Many a times, number 9 is assumed to be the predecessor of 0, and therefore option A may be chosen as the correct answer. Similarly, number names can be confusing and option 2 is chosen. But they're both wrong answers. When 1 is subtracted from any number, the result is the predecessor of that number, and when we add 1 to a number, we get the successor. Hence, the correct answer is option 3. Misconception 2. What is the number name of 113,180? Commas are used only in numbers, not in number names. Hence, option 1 and 2 are wrong. Option 1 is wrong because the number given has been written in the International System of Numeration, but the name has been written as per the Indian System of Numeration. The correct answer is option 3, where the number is as per the International System of Numeration and the number name is without commas. Misconception 3. Write the numeric form of 205,635. At times, 0 is missed out while writing the number from the number name. Hence, option 1 is wrong. In the same manner, due to lack of understanding of the International System of Numeration, options 2 and 3 may be selected, which are also wrong answers. With the correct understanding of number representation, option 4 is chosen as the correct option. We have now learned the misconceptions related to 6-digit numbers. Barring these misconceptions, your understanding of 6-digit numbers must now be perfect.
Today we will learn numbers up to 8 digits, numeral and number names, place value and expanded form. Large numbers consisting of 7 or 8 digits prove useful to us in many ways, such as expressing the population of a city, or to express the total area of a country, or to express the transactions at a bank, etc. While learning 6-digit numbers, we had created an interesting pattern. Now let's start learning even larger numbers by extending this pattern. If we add 1 to the largest number of 6 digits, then we will get the smallest 7-digit number, that is 10 lakh. And similarly, following the pattern, the smallest 8-digit number can also be obtained, that is 1 crore. While learning 6-digit numbers, we had used some indicators. If we add one more digit to it, then we will get a 7-digit number. Similarly, by adding one more digit to it, we will get an 8-digit number. For these new digits, we now need 2 or more indicators, which are 10 lakhs and crores. You might remember that the value of a digit based on its place is called the place value. Can you find the place value of this 3? Think about it. Since this 3 is at crores place, its place value will be 3 crores. Place value of 2 will be 20 lakhs. Similarly, the place values of remaining digits can be written like this. Now, we can write the number names of this number as 3 crore 27 lakh 56,423. In the same way, we can write the expanded form of this number like this. From the expanded form, we can say that this number consists of 3 groups of 1 crore, 2 groups of 10 lakh, 7 groups of lakh, 5 groups of 10,000, 6 groups of 1,000, 4 groups of 100, 2 groups of 10, and 3 units. By looking at many different symbols and numbers, one may get confused about which operation is to be executed first. To clear the confusion, use of brackets is an effective tool. To understand that the operation of multiplication should be performed first, we will express the operation of multiplication in brackets. Today we have learned numbers up to 8 digits, numeral and number names, place value and expanded form. In the next video, we will understand this better with a few more examples. Today we'll see examples of numbers up to 8 digits. Example. For the given number, write the number names by putting commas according to Indian system of numeration and International system of numeration. According to the Indian system of numeration, commas are used after 3 digits from right to mark thousands, then after 2 digits to mark lakhs, and then after 2 digits to mark crores. So according to this system, the number name will be written as 2 crore 43 lakh 56,655. According to the International system of numeration, commas are used after 3 digits from right to mark thousands, then after 3 digits to mark millions. So, according to this system, the number name will be written as 24,356,655. So, today we saw examples of numbers up to 8 digits. In the next video, we will clear some misconceptions related to numbers up to 8 digits. Today we'll see the common misconceptions and common mistakes related to numbers up to 8 digits. Misconception 1. Is 1 million equal to 1 lakh? Often there is a misconception that 1 million is equal to 1 lakh. This is a misunderstanding. To correct it, let's represent numbers in numerals. 1 million is expressed this way. The term million is used in International system of numeration. Let's write the number in Indian system of numeration. By doing so, we will get 10 lakh. That means 1 million is equal to 10 lakh. It is not equal to 1 lakh. To clear such confusions, one should have a clear understanding of Indian and International system of numeration. In the same way, let's now see some common mistakes. While adding or subtracting two numbers, they are often not written at appropriate places. This makes the solution incorrect. Keeping the numbers in their columns, operations are performed on digits located at the same places. This gives the correct answer. While multiplying two numbers, the zeros used for the place values are ignored. Such mistakes arises due to lack of understanding the place values. In this video, today we saw common misconceptions and common mistakes related to numbers up to 8 digits.
Today we will see conversion in units, its examples and misconception. In your life, you must have seen the use of metric system in many places, such as 8 cm length of the pencil, 5 milligrams of medicine in a needle, 500 grams of sweets in a box, etc. In many situations, we need to change the unit for this. The change of the distance, weight, and volume of units expressed in the table should be known. You can understand these changes by stopping the video. Let us now see some examples related to them. Rohan is measuring 2 line segments. The length of one segment is 30 centimeters and the other is 500 millimeters. What will be their total length? As you can see, in the given question, the unit of both the lines are different. It is necessary to make these units equal to find the total length. 1 centimeter is 10 millimeters. In this way, 30 centimeters is equal to 30 multiplied by 10 millimeters, that is 300 millimeters. Now we can add the measurements of the line segments when the units are equal. This will give us the total length of the line segments 800 millimeters. If we have to change this solution in centimeters, what will we do? Now 10 millimeters is equal to 1 centimeter. So 800 millimeters will have 800 divided by 10 centimeters, that is 80 centimeters. In this way, multiplication is always done when converting to smaller units and division is done when converting to larger units. If 5 milligram tablets are to be made from 2 kilogram and 250 grams of medicine, how many pills will be made? Here also, we have to make the units same. The amount of medicine is 2 kilogram and 250 grams. 1 kilogram is equal to 1000 grams. Thus, 2 kilograms is 2000 grams. By combining it with 250 grams, you will get 2250 grams. Still, the units are not same. Here, the gram has to change to milligrams. Since 1 gram is equal to 1000 milligram, so 2250 grams will be 2250 multiplied by 1000 milligram, that is 22,50,000 milligram. One such tablet of 5 milligram is to be made from this quantity. So, the number of tablets can be obtained by dividing them. With this, the number of pills obtained is 4,50,000. Now, let's look at a misconception. A tank has 2000 liters of water. How would you express 2000 liters of water in milliliters? Many times, it is misunderstood that division is done when converting to small units and multiplication when making changes to larger units. Option 1 from this understanding is a wrong answer. Similarly, sometimes the unit is ignored or it is mistaken. The correct understanding is that the fold is multiplied when converting to small units and the division is made when converting to larger units. This will give the correct answer, option 2. So today we have seen conversion in units, its examples and misconception.
Today, we will learn about estimation and approximation. Usually, we get the count of the objects by counting them one by one. Similarly, in some cases, we get the count by applying some method. The numbers that can be found by counting or by applying some method are called exact numbers. In certain cases, we can't find the exact number. In such cases, we simply do the rough estimation to find the number. For example, number of visiting guests, essential seeds for sowing the field, and sowing time, etc. The rough guess of any number is called estimation. How many marks you will get in the examination is also called estimation. Think about it. You got it right. On thinking, you would have understood that the marks you will get in the examination is also estimation. Similarly, in our daily life, we use round off figures instead of the actual numbers. For example, even though you arrive home at 3 minutes past 9, you will mention it as 9. In case you have to tell somebody if the distance between a city and a village is 2 kilometers and 115 meters, you will mention it as 2 kilometers. The way of expressing a number to its nearest number is called approximation. Can you give some more examples? Think. Let's see how approximation is done. We will understand it by the estimation to nearest tens. Focus on the last digit. If this number is among any number from 1 to 4, let us say 2 in this case, then this number will be closer to 0 than 10. Therefore, estimate the number by writing 0 in its place. If this number is among any number from 6 to 9, let us say 8 in this case, then this number will be closer to 10 than 0. Therefore, we will place 0 in its place and we will increase the value of tens digit by 1. Similarly, if the last digit is 5, as in 15, then the given number is estimated to the next 10. This means placing 0 at once and increasing the values of tens by 1. Today, we have learned estimation and approximation. In the next video, we will learn it better with some more examples. Today, we will see examples of approximation to nearest tens, hundreds, and thousands, and examples of estimating the outcome of number operations. Approximate the following numbers to hundreds and thousands. Focus on the last two digits. While approximating to nearest hundreds, if the number formed by these digits is among any number from 1 to 49, then this number is closer to 0 than 100. Therefore, approximate it by writing 0 in its place. Similarly, focus on the last three digits while approximating to nearest thousands. If the number formed by these digits is among any number from 1 to 499, then write 0 in its place, and if it is among any number from 500 to 999, then write 0 in its place and increase the digit at the thousands place by 1. Next example. Raman wants to buy a gift for his teacher. The gift item cost rupees 215. He has rupees 164. If his father gives him rupees 57, then will it be enough to buy the gift? Find it by estimation. By adding Raman's money with the amount he got from his father, we get rupees 221. If we compare it with the cost of the gift, we can find whether it is enough or not. But this is not required here. Rough estimation saves the time and helps in comparison as well. Therefore, we will find the value nearest to the result. Whenever there is addition or subtraction, let's consider the smallest number. Here, 57 is the smallest number. Then, find the highest place value of that number. The highest place value in 57 is tens. So, we will approximate both the numbers to tens place. The approximation to tens of 164 is 160 and of 57 is 60. Their total is 220, more than 215. Therefore, he will have enough money. Since the outcome is close to the actual result, it is meaningful and accurate. So, can we estimate these numbers to the nearest hundreds and thousands? Think about it. The result won't be accurate with estimation to hundreds and thousands. Next example. Estimate the given value 53 into 287. While estimating multiplication, find the highest value of both the numbers to be multiplied. Here, the highest value in 53 is tens and the highest place value in 287 is hundreds. Then approximate the respective numbers to the highest place. On approximating 53 to tens, we get 50. And on approximating 287 to hundreds, we get 300. Then multiply the approximated numbers, we get 15,000, which is both meaningful and accurate. Today, we have seen examples of approximation to nearest tens, hundreds, and thousands, and examples of estimating the outcome of number operations. In the next video, we will discuss some of the misconceptions related to estimation. Today, we will see some misconceptions related to approximation and estimation. Misconception 1. Approximate 12,748 to the nearest thousands. Many times, there is a misunderstanding that in order to approximate thousands place, it is necessary to have 0 at ones, tens and hundreds place. This is a misunderstanding. The correct way is that the number formed by the last 3 digits is 748, which is close to 1000. Therefore, it is nullified and thousands place value is increased by 1. Here, another mistake is very common. Sometimes we nullify the last 3 digits but forget to increase the value of thousands place by 1. Similarly, sometimes we add 1 to thousands place but forget to nullify last 3 digits. Misconception 2. Approximate 1487 to the nearest thousands. Sometimes, in order to get the solution, we assume to approximate to nearest tens, then hundreds, and then thousands. This is an incorrect way. The correct way is that if the number formed by the last 3 digits lies between 1 and 499, then it is nullified. This way, the number formed by the last 3 digits of 1487 is 487, which is close to 0. Therefore, by writing 0 at its place, we get the correct answer, 1000. Misconception 3. Approximate 81 to the nearest tens. If the digit in units place is 5 or greater than 5, then while approximating to the nearest tens, the digit to its left is increased by 1. Also, sometimes it is incorrectly assumed that if the number is less than 5, then the digit in tens place should be decreased by 1. This is an incorrect way. Lack of proper understanding of estimation and approximation give rise to such assumptions. The correct method is, if the digit is less than 5, then the digit in units place becomes 0 and there is no change in tens place. Therefore, the correct answer is 80. In this video, we have seen misconceptions related to approximation and estimation.
Today we will learn what are Roman numerals, their uses and the rules for writing them. In order to count, we need numbers, and to express the numbers, we need symbols. We use the Hindu-Arabic numeral system to express numbers using digits from 0 to 9. There are similar methods to express numbers. In this video, let us talk about an ancient system which is called Roman numerals. You might have seen Roman numbers while reading and writing. They can be seen in the school timetable, clocks, books, question papers, and many more. Let's understand this system. Roman numerals are generally expressed with the help of these 7 symbols, which represent 1, 5, 10, 50, 100, 500, and 1000. There are certain rules to use these symbols. Let's understand them. The number of times a symbol is repeated, its value is added as many times. Similarly, repeating the tens digit gives 20 and 30 respectively. Can Roman symbols be repeated any number of times? No. The symbols of 1, 10, 100 and 1000 cannot be repeated more than 3 times. Whereas the symbols of 5, 50 and 500 are never repeated. If the symbol of smaller value is written to the right side of the symbol of larger value, then their values are added. Just like adding 1 to 5 gives the number 6 and adding 10, 5 and 1 gives the number 16. Similarly, if the symbol of smaller value is written to the left side of the symbol of larger value, then the smaller value is subtracted from the larger value. Just like subtracting 1 from 5 gives the number 4 and subtracting 1 from 10 gives the number 9. The symbols of 5, 50 and 500 are never written to the left of the symbol of larger value. That means these symbols are never subtracted. The symbol of 1 can only be written to the left of 5 or 10. That is, it can only be subtracted from these numbers. Similarly, the symbol of 10 can only be written to the left of 50, 100 or 1000. That is, it can only be subtracted from these numbers. With this understanding, can you tell why Roman symbols cannot be written as given below? Think. As we had already learned, we cannot repeat any Roman symbol more than 3 times. Therefore, this way of writing is incorrect. Today we have learned what are Roman numerals, their uses, and the rules for writing them. Today we will see some examples of reading and writing the Roman numerals. Jatin was doing his holiday homework. He has to make Roman numerals from 1 to 10 with the help of matchsticks. Look at the chart he has prepared. Has he made all the Roman numerals correctly? We have learned to write the symbols of 1, 5 and 10. 2 is written by repeating the symbols of 1 2 times and 3 is written by repeating the symbol of 1 3 times. Has he expressed 4 correctly? No. Why so? This is because no symbol is repeated more than 3 times. So how do we write 4? Since 5 minus 1 is equal to 4, we write the symbol of 1 to the left of the symbol of 5. Similarly, since 6 is 1 more than 5, we write the symbol of 1 to the right of 5. Similarly, we write 7 and 8 as shown here. Now, writing 9 this way is incorrect. The correct method is by subtracting 1 from 10, which gives us this numeral. Next example. In a quiz competition, a teacher asked the students to write the Roman numerals for the numbers given below. Can you answer them? Let's write 14 in Roman numerals. To represent any number in Roman numerals, we first express it as a sum of the place value of the digits. Next, we write the Roman numerals for each place value, and then we write them together. 39 is equal to 30 plus 9. We write 30 by repeating the symbol of 10 3 times, and we write 9 by putting the symbol of 1 to the left of the symbol of 10. Then we write them together. 97 is equal to 90 plus 7. Here, we cannot repeat the symbol of 10 more than 3 times to make 90. The right way is to subtract 10 from 100, and we express 7 like this. Writing them together, we make the Roman numeral 97. 149 is equal to 100 plus 40 plus 9. We write 100 like this in Roman, 40 like this, and 9 like this. Therefore, writing them together will make the Roman numeral 149. Next example, convert the following Roman numerals into Hindu-Arabic numerals. Look at this Roman numerals. To convert them to the Hindu-Arabic number system equivalent, we observe the numerals from right to left. Following the rules, we can convert them to the Hindu-Arabic numerals. This symbol represents 5 and next symbol represents 1. Since this symbol is written before the symbol of larger value, it must be subtracted. The next symbol towards left is of larger value, so it must be added. Therefore, the result is 54. Now consider this Roman numeral. This symbol represents 1. After this, there is a larger symbol of 5 which must be added. The next symbol represents 100. Since this is also a larger value, it must be added. Next is the symbol of 10 which is of smaller value, so it must be subtracted. Therefore, the result is 96. Today we have seen some examples of reading and writing the Roman numerals. In the next video, we will clear some misconceptions related to Roman numerals. Today we will see some common misconceptions related to Roman numerals and clarify them. The rules to write Roman numerals are as follows. You can pause the video and review them once again. Misconception 1. How can we write 14 in Roman numerals? Due to lack of proper understanding of rules for writing Roman numerals, the symbol of 1 is repeated 4 times. This is a misunderstanding. Similarly, 14 is sometimes expressed as the symbol of 5 along with the symbol of 10, which together makes 15, and then to subtract 1, the symbol of 1 is written before the symbol of 10. This way of writing is incorrect. Similarly, because of the confusion regarding writing a symbol to the left for subtraction and to the right for addition, the symbol of 1 is written to the right side symbol of 5. This is also a misconception. The correct way of doing this is to write it as the sum of place value of digits. Here 14 means 10 plus 4. By putting the symbol of 10 and 4 together, we get the correct result. Misconception 2. How to write 99 in Roman numerals? Considering 99 equals 100 minus 1, it is sometimes expressed incorrectly as I see in the Roman system. The correct understanding is that the small symbols are written to the left side of the larger symbol to express subtraction. But while doing so, we must remember that a symbol of smaller value, such as 1, can only be subtracted from the two symbols that are larger to it, that is 5 and 10, whereas it cannot be subtracted from the symbols that are much larger to it, such as symbols of 50, 100 or 500. With this understanding, the correct answer is option 2. Misconception 3. Which of the following Roman numerals is expressed correctly? In option 1, the symbol of 10 is repeated 4 times, although no Roman symbol is repeated more than 3 times. Due to lack of this understanding, option 1 is considered as the correct answer, although it is an incorrect answer. Similarly, due to lack of understanding about the fact that symbols of 5, 50 and 500 are never repeated, option 2 is considered as correct. But this is also an incorrect answer. The correct understanding is that only the symbols of 1, 10, 100 and 1000 are repeated. But these symbols also can only be repeated up to 3 times. Therefore, with this understanding, option 3 is the correct answer. Many times, just by looking at the symbols, it is assumed that since all the given options are in Roman, all the options are correct. Here, the rules are neglected and option 4 is assumed to be correct. However, this is also an incorrect answer. Today we have seen some common misconceptions related to Roman numerals and we have clarified them.